To today's webinar offered by Grantek on our OEE Accelerator. This will be about using performance data to support your continuous improvement process. Here are some guidelines in order to enjoy and get the most out of today's time. First off, don't get distracted. There's plenty of opportunity in our world to get distracted by things, but there's also plenty of good content in today's webinar. So I would suggest maybe silence your phone, give your full attention to the webinar, and feel free to interact. And that means feel free to use the chat. We certainly are willing to take questions while the webinar is going, and take notes. And we actually have some poll questions as well, so feel free to answer the polls. Today, we're going to cover several topics. First off, I'll introduce myself, and then we'll talk a little bit about the current state of MES and how OEE fits into that. We'll spend a little bit of time talking about what OEE is and how it can help your operations, including a live demo of our OEE Accelerator. We're going to continue on and describe how continuous improvement can be enabled by OEE data, and talk about how you can use that to achieve some quick wins and set the stage for improved manufacturing capabilities. Finally, we'll wrap up today with a question and answer session. So be prepared. All right, let's start with introductions. My name is Jim Toman. I'm the Senior MES Advisor here at Grantek, and I have about 3 decades of experience in the manufacturing technology industry. Most of that time has been spent in the manufacturing execution systems space, or MES. That includes OEE, as well as a lot of other capabilities. And I've done a lot of different things in that space. I've done everything from building systems to managing projects to creating roadmaps and plans for customers. I've actually also run a quality group. And so I have a lot of background that lends itself well to talking about the topic today, as well as the other things that I do for everyday work with all of our clients. So let's get started by talking about the state of MES. And we're going to begin today with a poll question. Specifically, what kind of manufacturing execution capabilities do you currently have in your plants? Your choices are on the screen. Number 1, you could have a fully integrated electronic MES. Maybe you have some MES applications that you're aware of, like OEE or maybe statistical process control, or SPC. Maybe you don't have those yet and you just have spreadsheets. Lots and lots of people use spreadsheets. And so that's not an uncommon thing to see. Some folks are still using paper and clipboards, and there are folks who are just starting their journey and they may not know exactly what MES is. Any of those options are fine. If you would go ahead and answer the poll to your right, it would be great to see the results. And it looks like our top answers for the first poll are that about 1/3 of you have a fully integrated electronic MES. That's wonderful. And about 2/3 of you have some MES applications. That's great, actually. It turns out that we are pretty far along in the timeline for tools like OEE. It's a fairly mature thing. And it's not uncommon for folks to have either a full stack of MES capability, or perhaps they just have 1 or 2 applications. But either way, you can still learn today on how you might be able to use OEE to get better return on investment for your continuous improvement activities. Let's follow that up with the second poll question, which is, if you have MES capabilities, and it sounds like that applies to almost all of you, how do you mainly use OEE? Are you using it normally as a real-time indicator of performance? So in other words, maybe you have a dashboard on the screen and you look to see how things are going all day. Do you use it to create reports after a shift or a day to understand what happened on those shifts? Are you integrating it tightly into a continuous improvement process via the plan, do, check, act cycle? Or are you just kind of saying, hey, I have OEE, but I know what my downtime is, so I can improve my downtime based on the common causes? Or are you in a situation where you just don't use it at all? It looks like our Our top answer on this one is that we're using it as a real-time indicator of performance. So again, that's something I see pretty commonly as well, is that folks will have it on the screen, maybe even in the production area, sometimes on a TV, tells them how things are going, or perhaps they're carrying it on a phone, or they have it on a screen on a computer nearby. I also see that a lot of you answered that you're using it to reduce downtime based on the most common causes. Those are basic ways that people use OEE. They're actually probably the most typical ways that people do that. But you can actually use it a lot of different ways. And hopefully today we'll learn a few more of those. All right, well, thank you very much. Let's talk a little bit about setting the stage for where we're going to go next. Specifically, we're going to talk about OEE and how to get the best return on investment from it. Pretty much one of the things that a lot of people are maybe misunderstanding or have a little confusion about is that all manufacturers have a manufacturing execution system. They might not have an electronic one, but they have one. And a lot of folks have a hodgepodge of electronic MES capabilities. And what that means is that they may have an SPC system that was put in specifically to solve a particular problem, or they might have an OEE system that was put in particularly to solve a problem, but maybe those two things don't talk well together, or maybe they aren't integrated well to the rest of their MES capability stack. Usually in those cases, it's because they were brought in, again, to solve a specific problem, or they're driven by specific interests. The key question then is, if you have one of those kinds of systems, how can you use it to the best effect? Specifically today, because we're speaking to the OEE Accelerator, we're going to talk about how OEE is foundational to MES. It actually includes 3 different things that are part of its sphere of influence, if you will, in the MES space. It helps you uncover unrealized potential so that you can see where things might get better. It helps you capture value. So in other words, when changes are made, can we figure out exactly how much value those are going to bring? And then it gives you an accountability mechanism. So it helps you understand whether you actually did achieve the goals that you were aiming for. So specifically, let's talk a little bit about what OEE is and how it works. So as a performance monitoring solution, it's the industry standard KPI. And that's simply because it is easy to understand. Really, it's once you get past the math, and there is a little bit of math associated with it at the front, it really boils down to 3 things. It boils down to availability, throughput, and quality. And that tells you how well you're using your assets. It's easy to measure, or should I say it's ready to measure. Most systems are already set up that way, and they allow you to get things like how often it's available, what the run rate is, how many parts have been made, et cetera. And thirdly, it's immediately useful, but you also can do more with it. So basically you get it out of the box. It gives you a single number, which is fantastic. Everybody likes to have a number that'll tell them whether it's better or worse than yesterday. But it's also easy to look into the data underneath it that tells you a little bit about your downtime data. Maybe you can integrate it to production schedules, and you can add it to various other things as well in order to create more value for your system. So looking at the metric overall, let's talk a little bit about how it works. Essentially, you have several things in manufacturing that you can make more of. You can make more planned time for doing things. You can make more of that time available to production. You can run more, and you can make your time more productive by making quality better. What you can't do is make more hours on the clock. So if we think about OEE as a measure of how well we're doing versus the time we have available on the clock, then we can actually understand the metric a little more, a little better. So this breaks it out into 4 basic segments. The schedule loss is the amount of time that you lose because you've scheduled time where you're not going to produce. That might include breaks, maintenance windows, unstaffed shifts, holidays, et cetera. And then we get into the 3 legs of OEE, which is, and by the way, OEE is overall equipment effectiveness, just in case anybody's unfamiliar with the term. The 3 legs of OEE are availability, performance, and quality. You can lose availability by having events like unplanned downtime. Maybe you have unplanned breaks. Maybe you have people that call out sick and they aren't available to produce that day, etc. You can also have performance losses. That includes things like your line running more slowly than it should. Perhaps you are having issues with equipment jamming or things like that, and it causes you not to be able to produce at the full rated speed of that line. You may also have quality losses. For example, you're making parts or you're making things, but those things have defects and they require then rework or they require scrap. And so you can actually lose the ability to produce at your full rated speed based on those. Taking those three things together will tell you how effectively you're using that particular line or piece of equipment. So here's an example using actual OEE numbers over a particular scenario. And in this case, we're looking at a situation where we are able to, if we used every minute of the day, we might be able to produce 1,000 units of product. And that's if we have no schedule loss. In this particular scenario, let's say we were down for 2 out of the 8 hours on the planned production time, which means we can't make 1,000 units anymore. We can only make 750 units in a best case. And during the time that was available, we only actually ran 2/3 of the speed that we were expecting to run because it ran less than the full rated speed. So we had a performance loss that brought us down to 500 units made. And looking at the very bottom, we had a quality loss of 20%. In other words, we made 4 out of 5 parts well, but 1 part was made poorly each time. And so we were really only able to make 400 units out of the 500 that were possible at the speed that we were running. So in this scenario, our OEE really adds up to that 1,000 units that we could have made divided by the 400 units that we did make, and we actually have a 40% OEE. Looking at the top, you can actually see how you can multiply each of the different factors together in percentage to get to the OEE percentage. An OEE of 40% tells you something wasn't right, and that means you want to dig in a little further to see what was going on. So now we're going to talk a little bit about our OEE Accelerator and how it can actually show you a way to do this in sort of a live demo scenario. Our OEE Accelerator, very quickly, is a flexible, customizable tool set that allows us to bring OEE capability to a manufacturer very quickly and at a good price point to be able to turn on and create the insights that help people make performance improvements. We target it at folks who are using Ignition or interested in using Ignition. It is based on Ignition. Typically, it works best in process and discrete manufacturing environments, and it gives you a common set of capabilities that most folks are looking for, including performance insights, downtime analysis, the enablement of continuous improvement, and it is a launch point for smart manufacturing because it is a platform. It allows us to build other capabilities on top of it. Basically, it's pretty intuitive and easy to use, and it expands the Ignition platform to create the capability that you're going to see. So I am going to switch over to our demo system so that you can see what this looks like. This actually is from our demo system on our OEE Accelerator. You're looking at a set of data that is actually simulated data. So this is not from a live plant, but it is data that have been being collected into the system on a live basis. The simulation scenario in this case is a protein bar manufacturing plant. So we're making food products, and specifically we're making the protein bars on this system. We're going to look specifically at this Allentown site. This is a dashboard that shows the different plants that we might have. In this case, we have 2 lines. Actually, we have 3 lines, but we're running 2 of them. And this over here shows us how we're doing on each of those lines. You can see that line 2 is hurting. Line 1 is doing a little better, but it's not great. So we're going to go ahead and dig into this a little bit, and we're going to look at some of our dashboards. Specifically, we'll look at our OEE dashboard, and we'll pull up line 1 for that. So here's what the dashboard looks like specifically around OEE. And taking a broad view of this, you can see straight away that we have the largest circle here representing our overall equipment effectiveness number. That's our OEE metric. And then over here on the right, we have our availability, performance, and quality circles that tell us what each of those elements are. We can see what our target quantity is versus our actual quantity that's being made. And it tells us where we are. The top bar is our production run. So this began at about 12:30 p.m. Eastern time today, which is about an hour and, no, sorry, it's about, it's an hour and 45 minutes ago or so. And the current shift began at 7 a.m. and ends at 3 p.m. So we're almost through the whole shift. So basically what this means is we switched our run over. You're seeing that the screen is flashing up at the top, tells us there's some unplanned downtime event taking place. We have a jammed knife going on, and that actually is probably part of the reason we have a lower OEE than we would like in this scenario. And it's actually hitting our performance element down here if you look at our shift item. So let's actually dig into that a little bit. Let's say we want to learn a little more about the OEE impact of this unplanned downtime. We want to learn what we can do to make that better. We can go to our analysis and we can look at our analysis reports. We want to look at our downtime report specifically for line 1. And when we look at line 1, what we'll discover is that we have had 92 minutes of idle time overall, and we have a low occurrence count of that. Our unplanned downtime is pretty high, and we have a high occurrence count, and we've been running most of the time. So unplanned downtime seems to be the big issue here. And so what we might want to do is dig into that a little bit, and let's find out why. So we can go ahead and look at the downtime reasons for it. And this will tell us over this last time period that's reflected in the report up at the top, exactly how many of each kind of occurrence we've had on our equipment and what the overall durations of those things are. It looks to me like it's fairly common that we have an issue with our enrober or our slitter being jammed. We have a roller jam issue. Here's the most recent ones from today. We have knife jams, metal detectors, etc. Jamming seems to be a significant problem in this particular scenario. So what I might want to do is take this data away and say, hey, the reason that we are not making as much product as we possibly could is because our line is stopping all the time. And the reason it's stopping all the time is because more often than not, our slitter is jamming. And so we need to understand why that's happening and in what context that takes place. You can see that day by day it's different. And so there's probably some context here that would help us understand why it happens more on one day versus less on another day. And then we can go back and correct those items. So we would, in order to understand that depth of information and be able to know exactly what the best course of action is to take on that, you would use some continuous improvement tools with some additional data to ferret out why that particular scenario seems to happen, where it causes more downtime than we'd like and prevents us from making as much product as we'd like. And that's a very quick view of how the OEE Accelerator product works. We can certainly give you a deeper view of that. If you're interested, you can definitely contact us and we'd be happy to walk through it in more detail with you. But obviously it's a fairly easy to use tool that you can click through and understand what's happening close to real time. So let's go from that live demo, and actually I'm going to go ahead and make this bigger. We'll go from that live demo to talking a little bit about how we get quick wins out of this. And even beyond that, how do we set the stage to improve our digital manufacturing capabilities? So thinking about when we are getting information like that, what improvements could we possibly make? Obviously, in the 3 different legs of OEE, you might have different things. There could be things that would give you a better bang for the buck based on which particular element you have the most issues with. Maybe in availability, you can fix the biggest downtime reason and cut unplanned downtime by 25%. Maybe you've noticed on throughput that you're having issues that are related to operators and how they're using the machine parameters, how they're setting up the machine for the run. And you can do something with a retraining program to help them get that right more often, which would then increase your throughput. Or perhaps you're having issues with product quality and you're making a lot of bad product that you'd rather not make. And you could enter an SPC system into the mix, which, by the way, could be built as an extension onto the OEE Accelerator platform. And that might help reduce quality defects by 50%. These are just conjectures. We don't really know what makes the most sense in any given scenario until we look at the data, and it tells us a bit more about what the right thing to do is. So let's take a scenario example. For example, we might do a little bit of data collection. We're going to start off understanding what's the current profitability of a particular line. Let's say the line makes $1 million of profit per year. Then we're going to ask some questions. Of the time the line is scheduled to run, how much does it actually run? Well, most of the time it's up 75% of the time, but we have 25% of unplanned downtime. Okay, that's good to know. When the machine is running, how fast is it running compared to the ideal rate? The OEM rated the machine at 1,000 units a minute, but we normally are only making 660. So we're making 66% of what it could run at. Of all the parts that we do produce, how many are passing quality and are sellable? Well, we're making 80% of what we produce passing quality and 20% gets scrapped. So gathering this kind of data is important because it helps inform what we're going to do next, which is making decisions about what to attack. So what might be the best project? Here's the examples that we had a little bit ago. And let's talk about what our current state tells us about each of these products or each of these projects. If I'm looking at trying to fix availability as a component, then reducing unplanned downtime by 25% when my availability is actually pretty good could potentially yield $75,000 a year. And my OEE would equal 43%, which is a slight improvement to OEE, which still tells me there's bigger fish to fry, right? If I do a throughput project and I'm going to do a retraining program for operators, the goal would be to increase performance by 20. And that would yield a 79% level on performance and give me 200,000 of added value per year. If I did a quality project with an SPC system and reduced quality defects by 50%, I would bring my quality from 80% up to 90%, which would give me a small bump to OEE and give me $125,000 of added value. What it really comes down to is, number one, where's the best impact and what can you do? And it's not wrong to choose more than one project to work on. The data will tell you what the impact should be and how it should work. So let's take a look at some takeaways from this value scenario. If we if we look at what we were talking about and thinking about it in terms of the plant that you operate, what would you expect to find? Do you have the ability to find that information on every line all the time? As far as having it easily available, think about what the benefits could be. You'd have daily guidance. Every operations, maintenance, and engineering stand-up meeting could have an OEE dashboard showing you where to focus your efforts. You may already have that, but if you don't, it's a game changer. If you have a continuous improvement system, you could actually feed the OEE data into it to receive new light on what kind of returns you can expect to get from the projects that you might do. And if you do those projects, how do you know that they worked? That's where the accountability part comes in. If I'm measuring OEE before I make the change, and I'm measuring it after I make the change, then I should be able to see the change to OEE that I was expecting after making that change. And that helps me know whether I actually made the return that I was expecting. Like a lot of things, OEE without additional context doesn't tell you enough to know exactly what to focus on. So if we think about it with additional context, if I have OEE and I also have data about the people who are working on a shift and I know what shifts look like compared to one another, then I might notice that a particular shift or individual has reliably lower performance values than others. So basically what this tells me is there's something related to that shift that's different from the other shifts that I have that might help me understand what to do. Perhaps that might be organizing cross-training. So maybe we'll have some folks who are on a shift that runs better, training with people who are training people who are on a shift where it is not performing as well, so that the people who are on the lesser performing shift might learn some things from the ones who are doing it better. If I have OEE and I know what SKU I'm running on that line, then perhaps I can figure out if my OEE gets worse when I run certain SKUs versus other ones, because perhaps there's something about that product that I'm running, which is maybe causing the machine to trip up more often. Maybe that's the cause of my jams. There's something about the way the parameters are configured for that SKU, and I know what to go focus on. We could potentially work with our quality team and with engineering to develop new control strategies, which might be different machine parameters, or even rework the equipment slightly. Or perhaps I could work with the supply chain to establish different production expectations for that SKU. Perhaps we can get something with a slightly different material that doesn't affect the overall product, that runs more cleanly. Lots of different ways to attack those problems, but you need the data to know that that might be an option. If we have OEE and we have machine downtime reasons, perhaps I can understand whether a particular fault or a particular machine is the item that's feeding into my availability losses. I think a lot of us who just have our basic OEE machines today, we're already doing this. We're honing in on the particular machine. We're saying, hey, it's this particular item. We need to focus on that. We need to study it, figure out what's going on with it. And then we could create a continuous improvement project to repair or replace the faulty equipment. Or maybe you just go straight to a work ticket and say, let's go do it. So thinking about it from a continuous improvement perspective, essentially what you want to do is you want to bring data together. So OEE gives you some of that data, but other tools and other data give you other parts of it. In the quality world, without electronics entirely, you might have processes set up that, and I've seen this done on paper, I've seen it done a lot of different ways, where people will actually study, they'll bring a lot of different kinds of data together and they'll study how that data correlates. They'll use statistical methods to make sure they're right, and then they will go and make changes and then check on things. But data by itself doesn't always tell you the whole story. Sometimes you need the context of people. So one way, you could do this is you could bring the defect rate data together with product measurement data and feed it through SPC. And if you put SPC in a live setting, you can see as product is being made, whether it's approaching or exceeding control limits on that data. A second way to do it would be to bring the defect rate data together with operator data. So for example, if you know who the operators were that were on that thing, you could try to understand the relationship of specific operators to specific defects and figure out where the outlying parts are, and be able to identify the specific folks that maybe need to be retrained, or perhaps we can just inquire a little further to find out why there's more issues there. And obviously, I just used the question why. 5 why. The 5 why question process and fishbone analysis are fantastic tools that are often used in continuous improvement to get down to the root cause. And obviously, if you're trying to fix something, you want to know what the root cause is. And you can use data collected by the OEE system to verify the anecdotal data that people bring to the table in order to determine what a root cause is on something and make corrections. Now, if you happen to have a fully integrated MES system, it might take you less effort, because you may have all that context data readily available and timescaled. So you could actually do a query against that system that says, on this day when we were seeing these events and we had this low OEE performance and it was related to quality, who was working on that shift on the affected machines? What products were we running? How does that compare to other times when we've run those products, and et cetera? And you could actually get all that data collected very quickly into one place to be able to make very rapid decisions on what to try to, what potentially might have been the root cause and what you could potentially try to fix. The more electronic it is, the more data you're collecting in an organized way that has good context, the easier it is to bring that information together to make the right decisions. All right, so you might be asking, how do I get started? Basically, what you want to do with OEE is you want to understand the situation that you have. In other words, you want to take a look at your manufacturing lines, understand what you have. You want to be able to produce production loss summaries. You want to understand the improvement potential. You want to use the data then to do improvement planning, and using the right tools for that is important. Electronic tools can make the process faster. You want to quantify what your goals are as you get into that. And then you want to drive the improvements. You want to make sure that you're actually doing the things that are important. Sometimes they're quick and easy. Sometimes you might have to actually put together a project and have the project funded in order to do it. But if you're using data from a system like OEE, you should be able to produce the right projects that give you the right benefits and produce the right improvements. So in summary, the ROI of OEE comes from using it as a tool. OEE by itself does not deliver value except in the data that it creates that you can then apply through, for example, a continuous improvement system. You can use the downtime, the throughput, and the quality data, and you can actually use that data over a period of time to pinpoint the right corrective actions. But you can then use the OEE system, the same system, to verify that the improvements had the desired effect. And that's because you're directly measuring that process at a level that gives you a score before and after you've made those improvements. Our OEE Accelerator, which you saw earlier in the webinar, it actually gives you all of that. That's part of the basic package. It gives you real-time monitoring along with the extra metadata. And more importantly, it also has an extensible platform that allows us to add other MES capabilities on top of that. So we can extend it into quality, or we can extend it into traceability, or any of the other things that people commonly bring into the realm with MES. So with that in mind, I'd like to open the floor for questions. And let's see if I can help you out with anything that you might also be interested in knowing. All right, so it looks like I have question number one. Does the OEE Accelerator include continuous improvement tools like SPC, box and whisker charts, or 5Y tools? Fantastic question. So the OEE Accelerator tool is designed to provide you the data that feeds into those kinds of tools in a proper continuous improvement system. Most companies that are doing manufacturing at scale already have those kinds of tools in their tool belt. And they're often fed with contextual data that's not necessarily coming from the same domain. So we don't actually include those tools as part of the OEE Accelerator, but we do allow you to take the data out of OEE Accelerator on reports and through export so that you can feed the tools that you do have. There are some fantastic, very specialized analysis tools that are out there. And I'm thinking specifically of things like Minitab and some of those tools that companies often use when they're trying to make statistically based improvements. All right, so looks like I have another question. After I use OEE to identify a continuous improvement project, how do I know if the improvements were successful? Again, what you would want to do is you would want to make sure that you are measuring OEE and its constituent legs on a particular line or a particular piece of equipment before you make the improvement and then after you make the improvement. So essentially you would be looking at the data for that same machine or that same line and comparing the before and after to understand whether the OEE value is higher or lower after the improvement was made. Hopefully you've made a difference and it's a higher value. And so that you can see that the improvement actually did have the result that you were intending. Okay. Well, let's see. Another question. What are some common pitfalls or misuses of OEE? So OEE is one of those things that has been around long enough, and it's been around long enough for people to develop different ideas about what it's good for. There are some common ways in which I've seen it misused. Probably the biggest is in trying to take OEE to a too granular focus on things that are not similar enough to really do a comparison. So for example, I might be comparing the OEE on a particular line of product and trying to compare that number directly to the OEE on a line in a different plant that makes something else that's not even the same. The goal of OEE is not necessarily for horse racing. The goal of OEE is to understand what the utilization of a particular piece of equipment or a particular line is in order to optimize that piece of equipment or that piece of line or that particular line. And it does that by giving you information from the context world of that particular thing. Is it possible to compare a number from one to another? Sure, you could, but what does it really mean? Does it mean that you haven't optimized it well enough, or does it mean that you've aligned the conditions so similarly in the two different environments that you can make an apples to apples comparison? I've kind of yet to see that done effectively. Usually where it's used best is as an enabler for continuous improvement. Okay, so I have another question. How does the OEE Accelerator grab the data for KPIs? It is using, it's in Ignition, and it's using data that's fed to it from the control system. So that would include PLCs and other devices on the plant floor. And it's summarizing that data through a back-end engine, which is an OEE module that we have incorporated from a company called Sepasoft. That OEE module is what's doing all the contextualization of the data, and it's summarizing it in close to real time and then storing it in data tables where we can query it back out for display. We can also put a real-time live display on the screen, as you saw, based on that information. Specifically, as far as how it's grabbing the data, it's possible to grab it through whatever mechanism is available to Ignition. So Ignition is native with OPC UA. It can collect data through any OPC server, including Kepware or others as well. And it also can collect data over MQTT. So lots of different ways to do it. That data, the more automated it is, the better. All right, another question. Curious, what is used from Sepasoft and what is custom built? So I kind of almost spoke to this question a second ago. We are using the OEE module from Sepasoft in the back end. It is not in the front end as much as it is in the back end. Most of what you're seeing on the screen in the demo is really what we have created as a toolkit to enable rapid deployment. It creates a common menu, and it allows us to create a common look and feel so that as we add other functions to MES capabilities, what you get is a very clean presentation that is consistent from capability to capability so that you can actually move through different parts of your system and it looks good and it's clean. We usually will slightly customize that for our customers by adding their logos where needed or changing the colors and things like that. But as far as Sepasoft is concerned, it's mostly back-end processing that we're using it for, and it's very good at it. Okay, another question. From initiating a project to complete deployment, how long does it take to deploy OEE Accelerator? Very good question. So it is going to depend on the scale to which we are deploying it. A relatively simple deployment that involves a single line with a few machines could be done very rapidly. We're talking 6 to 8 weeks tops. If you're doing a larger scale deployment where you have many lines and we're trying to roll it out across all of those, there's still a fair bit of configuration and testing that has to be done, so it would take somewhat longer. But we're not talking about big bang MES projects that take years to deploy. Typically, we would be doing this on a smaller time scale. The whole goal of OEE Accelerator is rapid time to value. All right, what are the limitations of using OEE to compare the performance of different lines or plants? Spoke about that a little bit ago as well. Essentially, the reality is that when you're comparing from different plants to different plants and you're comparing from line to line, usually where you will see the best results from doing that is where the plants are producing the same products at essentially the same equipment, and for the same purpose. And so the more similar they are, the more valid that comparison is. The more different they are, the less valid it is. It isn't to say that you can't do it. So for example, you might want to say, hey, you know, if your goal is to understand, can I make product X better at this plant that has older equipment versus this plant that has newer equipment? It's the same product, different plants, different equipment. That might be valid. It might be a good idea to compare those two numbers to see which one performs better. But you want to make sure you understand what the common thread is. If you're just comparing numbers to compare numbers, it probably is less likely to have a good impact. All right. That was the last question. Thank you everyone for attending today. I wanted to let all of you know that all of our attendees will be sent a recording of today's webinar. And if you have any additional questions after we're done here, feel free to send them via email to info@grantek.com. It's right there on the screen. And we'll be happy to get back to you as we can. Once again, thank you and have a great day.